Welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra. I'm your host, Mr. Takeda, and I'm going to teach you some algebra right now. This is lesson 3.3 on function notation, in which we ask the essential question, how can you use function notation to represent a function? Okay, so something very little different here. This is interesting. Let's get going here. Okay, so function notation, it's a shorthand way of writing math. So when we say shorthand, what does that mean? That means a quicker way. It's like an abbreviation. That's another way to think of it. So what we do is we give a function a name, or we give we give a function a name. So we call it like f or g. Those are the names of these functions. And for this, I would say f of x. Oops. I don't know why I put that in parentheses, but f of x or g of x. Right. And we define it usually by an equation, right? So f is defined as 3 times x plus 2. G is defined as negative 2 times x plus 1. Okay, well, how does that work when we're doing math? So here's the example from the book. Evaluate f of x when negative 4x plus 7 equals, negative 4x plus 7 when x equals 2 and x equals negative 2. All right, so the first thing I'm going to do is write f of 2, because that's the first one that we're doing, right? F of 2 equals negative 4 times 2 plus 7. All right, so so f of 2 equals negative 4 times 2 is negative 8. And negative 8 plus 7 equals negative 1. That's it. There's my evaluation. When we say evaluate, that means what's the value of f of 2? And then we'll do f of negative 2. F of negative 2 equals negative 4 times negative 2 plus 7. See, I'm just substituting here and here because I need to know what my input is, because at the end, look, at the end, there's no x over here. The input's only shown over here. So f of negative 2 then, negative 4 times negative 2 is 8. And 8 plus 7 is 15. So f of negative 2 equals 15. And there's my two evaluations there. Okay, you can pause this here to get this in your notes, to look at it, to ponder it, to ask yourself, what did he do here? And plumb the depths here and figure this out. What did I do? It's all in front of you. And then try this one. Pause the video here, try it, make sure you do neat work and clean work, because at the end you're going to be asked to put this answer into the pod. Example 2. Interpreting function notation. So this is just a matter of reading this and understanding what it means. It says f of t, so I see all these are f, right? We have different inputs, 0, 6, 3, and 9. That's going to be the outside temperature t hours after 6 a.m. So it's going to be some number after 6 a.m. In this case, the variable t is what it takes the place of our input. It's our x in this case, right? So f of 0 equals 58. Well, this is 0 hours after 6 a.m., so this basically says that at 6 o'clock, at 6 a.m., the temp is, I'm going to abbreviate, temp is 58 degrees Fahrenheit. Right? That's what this says. The second one, oh, look, they put some variable in here. That's weird. But it's 6 hours after 6 a.m., so at 12 p.m., or noon, or however you want to say it, the temp is n degrees. We don't know. All we know is that it's n degrees Fahrenheit. Look at this, thinking all algebraically, just swapping back and forth from ideas and numbers and letters. Oh, look at us. Okay, so we have two statements here, f of 3, and we have is less than f of 9. So this is 3 hours after 6 a.m. would be at 9 o'clock. At 9 a.m., the temperature is less than at f of 9 would be 9 hours after 6 a.m., so that would be 3 p.m. I would hope so, because at 9 a.m. it's still morning, 3 p.m., the middle of the afternoon. Okay, so we're interpreting these things here. So if you're not sure how I got the 9 a.m., the 3 p.m., the 12, and all this other stuff, look at it again. It's hours after 6 a.m., so I'm starting with 6, I'm counting up. Example 3, solving for the independent variable. This again. Find the value of x for which h of x equals negative 7. Okay, so when they say the independent variable, they're talking about the x, right? So what we're going to do here is we're going to change this back to a y. We're going to change this back to a y. Y equals 2/3 x minus 5. And then we're going to substitute the negative 7 for the y. Remember, the h of x is kind of like our y. It's our output. So negative 7 equals 2/3 x minus 5. And then we solve for x. Okay, so I'm going to add 5 to both sides. That's 0. This is negative 2 equals 2/3 x. And then to turn that into a 1, I'm going to multiply both sides by the reciprocal, which is 3/2. Because 2 divided by 2 and 3 divided by 3. Okay, so negative 2 divided by 2, negative 1. And negative 1 times 3, negative 3. There we go. So the value for x that would return a negative 7 is negative 3. So in other words, if I put h of negative 3 equals 2/3 times negative 3 minus 5, I would get negative 7. All right, so that was fun. So try this one. So pause this here. Do the same thing. Try it here. You're going to try and find the value for x, the input for which the output is negative 4. All right. Pause it. Do a good job on your notes because I'm going to ask you this question at the end of the pod. Example 4. We're going to graph a linear function in function notation. All right. So what we're going to do here, our most basic way of graphing these things is called using a table. We're going to use a table. And now I put y, but let's use f of x because I want to stay consistent here. Oh, sorry. Sorry, that looks so awful. Okay, so when we graph these things, we need 3 points. We need 3 points to make sure if there's a mistake on one of them that we will recognize it because they won't be in a straight line. And we also want to try and stay around the center of the graph because I think it's easier to think of if we use negative 1, 0, and 1. That way my graph will be right in the middle. If we start using these big numbers like this, if we start going 3, 4, 5, now all of a sudden we might be off the top of the graph. But this should work for us here. So f of x, this would be, let's see, f of negative 1 would be 2 times negative 1 plus 5. So negative 2 plus 5 is 3. So negative 1, 3. So I'm going to write those as an ordered pair. 0, well, 2 times 0 plus 5. 2 times 0 is 0, and 0 plus 5 is 5. This is a special point in that whenever x is 0, the output, the y value is going to be whatever is added at the end. And then finally, if my y value is 1, 2 times 1 plus 5. 2 times 1 is 2, 2 plus 5 is 7. So 1, 7. Okay, let's plot these points. Negative 1, 3, 0, 5, and 1, 7. See, if I would have used bigger numbers for my output, I'd be kind of off the top of this graph here. I'm going to connect these with a straight line. There it is. like that. Hopefully that wasn't too bad for you to see. And let's see. Grading on a curve, get it? Well, that's it for now. And I will see you in class when I see you. Finish the pod and have a great rest of your day. Bye-bye.